So hi everyone, I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So in this video we will talk about the fourth approach to solve this problem, which is merge case sorted list. In the previous video we have already talked about the brute force and the optimized approach. In total 3 approaches we have already discussed in our previous video. I'll attach the link somewhere here, and now we'll see the fourth approach. So the fourth approach is basically called divide and conquer approach. Divide and conquer approach. So using this approach we have already solved or learned merge sort algorithm, remember? So the same approach we will apply here also. So previously where we have to apply the merge sort algorithm, there we had numbers, if you remember, 2, 5, 4, 3 for example. So we know that whole array is not sorted, so we divided this into 2 halves, 2 and 5 together, and then 4 and 3 together. Again these are not sorted, so we divide this further into halves. So 2, now 5, similarly 4, and now 3. So we can say yes, 2 is sorted, 5 is sorted, 4 is sorted, and 3 is sorted. So I can say when 2 and 5 are sorted, so let's merge them. So when we merged this together by using the merge algorithm, means the sorted element will come first and then the larger element. So now 2 and 5 became merged in the sorted manner. Similarly, in 4 and 3 when we merged, so 3 came first and then 4, and now we can say 3 and 4 has been merged. So now first we went deeper and deeper, we can say recursively, and now after merging we are returning back to our parents. So here I can say 2 and 5 are sorted, and here I can say 3 and 4 are sorted. So again we will merge 2 and 5 and 3 and 4. So when we merge 2, 5, 3, 4, so we will apply the same concept in start I pointer from here, j pointer from here. Again I is shorter, so in the new array add 2. Next time move I plus plus. Again 5 and 3, 3 is sorted, so again put 3, next time 4, next time 5. So at the end I can say yes, 2, 3, 4, 5 has been sorted. But that was about the numbers. Here it's about linked list, if you remember, correct? So we have to merge sorted linked list. But can I say, I don't know together these are merged or not? No, it's not. Correct? Why? Because 1, 4, 5. If it was like 6, 7, 8, we can say yes, together also it's already sorted. Correct? But as of now it's not sorted. So I can say na ki break this until it becomes one size. One size list. So one size list I can say it's sorted, because the question also mentions ki every linked list are sorted on their own. Correct? So that's what we will do, as this is list. So I know indexing will be there 0, 1, 2, 3. So now I will calculate the mid index. So mid index will be nothing but left plus right divide by 2, or left plus right minus left by 2. I hope you all know when to apply which method, okay? Because we already have discussed about this in our binary search playlist. Okay, so we have calculated mid. So for this 0 plus 3 divided by 2, 1.5 means 1, can I say? So this will be our mid index. So what I am saying, towards the left, let's send 1, 4, 5 and 1, 3, 4. That's it. Towards the left list, yes. And towards the right list, 2, 6, 2, 5, 7. Means can I say from, this was our left and this was our right, right? So from left to mid, this is our left half, and from mid plus 1 to right, this is our right half. Correct? Now we will again break this. Why? Because it is not sorted. So we will divide this further. Why? Index is 0, 1. So mid will be 0 plus 1 divided by 2, which is 0.5. Can I say 0? So 0 will be our mid index. So from left to mid means 0 to 0 will be our left. So can I say 1, 4, 5? Yes. Now mid plus 1 to right. So can I say 1 to 1 means 1, 3, 4. Now I can say that this is of size 1 and this is of size 1. And as the question itself mentions that every linked list inside the lists are sorted. So I can say yes, it is sorted. Correct? So when the size became 1, how can I say size is 1? Because in our function call, when we are sending, so in our every function, we are sending the lists, we are sending left and right. Remember? So when we called for left side, after mid calculation, for our left, what we sent? List left until mid, correct? So in the next call, our mid will become the right index, correct? Now for right, what we have called? For right, we have sent list, yes, mid plus 1 and right, done, yes. So now For every call we are getting our left and right. So when the size is 1, can I say when my left is equal to right? Means when my left is also pointing to the same index and right is also pointing to the same index, I am talking about not inside this but this 0, 1. Okay, so left is also saying it's 0 and right is also saying it's 0, means I can say it is of size 1. So no need to break further, means return. So can I say the base case will be if my left is equal to right, return. Now this return will be return to this functions. Can I say? Yes. Here only we called, right? Function. Okay, here only we called. So when 145 went for this function call to break further, so left was also 0 and mid was also 0, correct? So they both returned, correct? So when they returned, can I say in my left we have 145, in my right we have 134. Done. Now I am standing with one linked list which are sorted in itself and for other linked list which are sorted in itself. Now what is my task? To merge it, because both were sorted. So if both are sorted, we have already discussed a problem where we have learned how to merge two sorted lists. So here also can I say I have two sorted lists only at the very bottom of the function calls, left and right. So what to do? Can I say after this let's call a merge function, and in that merge let's send left and right. So now I can say ki 145 and 134 will get returned, correct, for the merge. So now 145, next time 134, and how we merge we all know. How we merge? Start our L1, start our L2, whatever is sorted connect to the dummy node. Okay, 1 next time, 1 next time, and so on. This question we have already discussed. I don't want to discuss it further here. I'll attach the link somewhere here. Go and check out if you have missed that question. Okay. So now after this I can say yes, 145 and 134 will get merged. So can I say 1, 1, 3, 4, 5 after merged? Yes, 4 2 times, right? Okay, 4 and 5. Done. So now when this will get merged, this, when we call the merge function, this will get returned, and this will get returned to what? Can I say either left or right? Because from here only we have called the functions. So now next time this will become someone's left or right. So as you can see here now in the function call, when this will get merged, it will get returned. So can I say for this bigger code, this is nothing but left. This is nothing but left, which is already sorted, correct? Now the same approach we will apply here also. Again we will break into 2, 6 and into 2, 5, 7. Further we will apply the merge to sorted list concept, and it will be returned after sorting. So can I say 2, 2, 5, 6, 7. So now this will become our right. So this is left, this is right. Again this is also sorted and this is also sorted, correct? So we will apply that again further merge to sorted list concept here. Okay. So this was our final approach in this. As we are dividing at every steps, see this, here also I can say, let me erase, here also I can say when we will divide this, it will become 2, 6 and it will become 2, 5, 7. But at every step, the number of nodes, if you count the number of total nodes, can I say size is n and number of lists were k. So can I say total number of nodes will be kn? If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here also see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So at every levels they are n. And how many levels are there? For 4 number of nodes, the levels were 2. So can I say it is nothing but log k base 2? Yes. And number of nodes? Correct. So hence the time complexity for this is n log k. Okay, for this approach, merge k sorted list. Okay, if we talk about the space complexity, obviously if we are if you are merging, there are 2 ways to merge also we have discussed. By taking extra space complexity means when we will merge it, when we will decide which node to take, then you have 2 options. Either create new nodes, connect to it, or else play with the same lists. Play with the same list means if this is shorter, right? So to its next, disconnect this 4 and connect this 1. And if you are disconnecting, save 4 somewhere else. So all these methods we have already discussed. These are the space optimized code which we have discussed in our merge to sorted list. So if you know that, definitely you can do this. So space complexity can be linear or constant depending upon you are creating a new linked list or you are playing with the same linked lists again and again. So here is the code which we have discussed. The main function is this merge k list. First, as a question constraint mentioned na, the number of nodes can be 0 also. Remember, the number of nodes can be 0 also. So hence it is very important to check what if our list is null or the size is null. Okay, so we'll check if linked list list is null, means list does not exist, or else list exists but inside this linked list does not exist. Then we will return null. Otherwise, our task is to divide. Divide means take the mid index. So for the mid index we want left and right. So hence the left will be 0 and right will be final. This is our divide function where we are getting left and right. First we are checking what if both are pointing to the same index. It means the size of the list is just 1, means no further division needed. So hence we will return that same list of left or right as both are same, right? Otherwise we will calculate the mid index, and towards the left side, means L1, we are saying we will send the indexes from left to mid, and for right side mid plus 1 to right. Now once we get the return for L1 or L2, means I can say L1 and L2 are of single length and they are sorted. So if they are sorted, now I can say both are sorted, and it is nothing but now the question becomes merge to sorted list, and hence we will call the another function. We will send these two linked lists which are sorted, and in this function we are actually returning the code. So here you have two ways: either play with the same lists to merge, or else create a new linked list to merge the two lists. Okay, so that's it. This was your merge to sorted list concept, this was your division concept, and here is your actual main function. So I hope you understood. Let's run the code. Done. Let's try to submit this. As you can see, it has been submitted because the time complexity is n log k. Correct? So this was your code in Java, and here is your code in C++ for the similar approach if you understood this, and here is your code in Python for the similar approach if you are from Python background. So if you understood this way, and along with that the three ways which we have discussed in the previous video, then definitely I can say ki the last question of this merge sort has been completed. So that's it for this video, guys. If you have any doubt, please do let me know in the comment section, and also let me know what approach did you like for this question. And that's it. You will get the sheet link and the social media link in case if you need any guidance in the description below. And that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.